Assalamu alaikum again. We have a topic today, confidence interval, and we have two different domains like confidence interval for population mean and confidence interval for population proportion. And we are going for the conceptual understanding. What is the concept of confidence interval and the formulas? Which formula is more suitable for the particular uh, requirement of the data and available information. And the first is confidence interval for population mean. We have to find the estimation, interval estimation using sample data, sample information. So first of all, we want to estimate the population mean confidence interval for population mean. The first method suggested is sigma is none. When sigma is none, we definitely uh, don't need to think like just apply the formula x bar left-sided formula, like I'm just using another color. So green color is I'm using the green color, like x bar plus minus z sigma by square root of n. These formula belongs to two-sided, like two-tailed, because we are using left side and right side, both we are going to find out. The next is confidence interval for population mean when sigma is unknown, where we have two scenarios. One scenario is when n is large and other is n is small. N large means usually we say that like n is greater than equal to 30, and when we use the formula like x bar plus minus z capital S by square root of n. Capital S means like this capital S shows the biased standard deviation, and another method is n is small. When we are using x bar plus minus t s by square root of n, we are shifting to t distribution. Why? Because we knew that like sigma is unknown and n is small. This is a condition to shift the distribution from z to t distribution. The only condition is like sigma is unknown and n is small, and we are using small s. Small s means unbiased derivation. The last you have seen the formula as well, the concept like unbiased derivation. The last one is confidence interval for population proportion. The proportion means like we will find out number successes and divided by the sample size, and we'll get the p as a sample proportion. And if we have the data of population proportion, we should use the population data. If not, then we will use sample information to estimate uh, the confidence interval as well as population for population proportion. So this is the main crux of all the chapter. Then I will continue the next step. So next is this is one of the formula that we have seen previous in the previous lecture. So these are the table values. This is margin of error like x bar plus minus z sigma by square root of n. So these are the different effects when we are decreasing margin of error, the sigma standard deviation variation will decrease as well. Margin of error is decreasing, then sample sizes are increasing, then as well as like margin of error is decreasing, then level of confidence 1 minus alpha will be decreased. So we have an example in the last we have explained in the very good way, like in the shorter version I explaining when we have 11 circuits from the thousands of circuits, and we have a mean resistance is 2.2 and the standard deviation is 0.35. So for the easy understanding, like you can see that, so here is a sample size mean n of like 11, and the mean value is like x bar is 2.2, then standard deviation is 0.35, like we have sigma is 0.35. Why we are using population? Because written is population standard deviation, that's why we are using sigma. So otherwise we can use as a S sample standard deviation. Now we want to find the confidence interval for 95% confidence interval. That's easy to solve. The next step is just put all the values in the formula. Then we are getting the answer is 1.992, 2.4068. So the easy interpretation is we are 95% confident in the two mean resistance between this one and this one. So although the two means may not be in this the interval, it's very clear cut like the explanation. It doesn't mean we are taking the sample and the value of the sample will lies between this interval. So incorrect interpretation is 95% probability that is interval contain the two population mean in its whole crux. So next is when a population mean is unknown. When unknown, we will shift, we maybe shift in the t distribution, and the formula is x bar plus 1 is t s by square root of n. Here is the new small concept is degree freedom. Degree freedom is a number of observations that are free to vary after sample means have been calculated. Degree freedom, usually we use n minus 1, any sample size, just use, see the sample value number, like if 10 and 10 minus 1 is 9. So this is a complete structure, and this is the way to find to identify the table value. We have degree freedom in the left side and row wise. You can see the column wise are the 1 minus alpha, or we can say 1 by alpha by 2, or alpha, or uh, level of significant level, or we can say confidence interval. So there are different kind of tables. You see the table, which kind of the table, then you get the value related to the scenario, related to the table. So if you want to find the value from the table, it's very, very easy. Like you have seen, like n is equal to 3. Just you find out the degree freedom. Degree freedom is n minus 1 is 2, like 3 minus 2, 1 is 2. So use the value as a 2, and the alpha by 2 is 0.05. So use both the values, like 0.05, this one, and the degree freedom is 2. Just you have the value is 2.920. This is the table value. Same like just अपने उसको z table में देखा था. So the next is the these are few values. If you want to use these values, just most welcome. So this is a question, like n is equal to 25, x bar is 50, and smallest 8. 95% confidence interval we want to find for mean. So just got the value of degree of freedom like 24, and the t value from the table is 2.0639, and just we are putting the value and getting two different answers. So next step is you can interpret the same like previous interpretations. The value 95%, the values lies between 46.692 to 53.302. So this is the main crux, like main formulas I've taught you for confidence interval for population mean. Okay, the next approximation for large sample. Usually we consider different examples, different scenarios we have seen in the previous chapters. Usually when we are increasing sample size, then we are getting the more precise results. Uh, while when you are increasing sample size, we are getting the more precise results, more accurate results. If we are going to the nearby the whole population, sample size going to the population, approaches to the population, then the results are more flexible, reliable, and consistent, and you can say unbiased results will be different. So determination of sample size is very easy method to just three values we need to put it here. Like first is Z values coming from the 95% confidence interval or etc. Like sigma will be given in the question, and the E is the margin of error. Margin of error means like the area. I'm just explaining again. Like for example, this formula is written like Z sigma by square root of n. So this area, like after plus minus, this area will be known as like E, margin of error. So this is the point estimate plus minus, and we will say like margin of error. So if we considering this one critical, other than critical value, we will say like standard error. So in the separate, if you found anything, like you can identify this is the point estimate, critical value, and standard error. If we combining both, and we can say that margin of error. So the next we are uh, going to understand just how we can calculate. Just use can see sigma is 45 and 95% confidence interval. We want to find the sample size with plus minus 5 is margin of error. Just we are putting the value and getting 220 is the sample size value. If sigma is unknown, I've explained already in the detail in the first slide. The last method to okay, now we are going to start like confidence interval for population proportion. Usually we have to get the concept of population proportion before start of the topic. Initially we understand proportion belongs to the ratio of two numbers, and how we can get like just the formula is x by n. X is the successes, number of successes. Like if you want to get the proportion of male student in the class, just number of male student divided by total number of students, you can get the proportion of male students as well as female students. So the next step is to understand, this is not compulsory, but you can use if you want to get the earlier things. Usually, the population values will not be given in the questions. Like if yes, then you will use the first formula, the first concept of standard deviation, population standard deviation. If not, then we will use the second one, the sample proportional formula that we have seen in the last formula. This is the same formula I've taught you in the previous slide, like P is a sample proportion, plus minus Z square root of P into 1 minus P divided by N. Just Z is a standard value and the P is the sample proportion, as well as pi is the population proportion, because we are estimating for the population parameter and on the basis of sample data. So N is a sample size. We have an example like a random sample of 100 people shows that 25 are left-handed. It means we have 100 as a total, like n is 100, and we want to find the confidence interval for left-handed. Means left-handed are is your target, your successes, then x is 25 and n is 100. Just you can get the whole solution. So we have different ways to find. This is not need to find the second step. Just we have a formula p plus minus z square root of 1 minus p into 1 minus p. You can write in the last. So and divided by n. So just put the values and you will get this one and again this one. So this the interpretation of the population proportion confidence interval will be explained in the percentage. So we can say that 16.5% to 33.49% chances for the left-handed 95% confidence interval. So we have many examples in the book. We will going to for the next step. Like we are 95% confident that the true percentage of left-handed in the proportion is between 16.51 to 33.49. although this range may not contain the population proportion. 95% confidence interval formed from the sample of the 100. Like the same, like you can find out for right-handed. So this person I've solved for the left-handed. You can solve as well as for right-handed. Right-handed, how we can identify the right-handed? Of course, out of 100, like 25 are left-handed and 75 will be right-handed. So this is the main crux, and this is the formula to find out the sample size for population proportion. So n is equal to z squared pi into 1 minus pi divided by e square. So what is sample size? You can find out by this example. This is very like 451. So it is very important. You have to find the sample size. If you are getting the value in the decimal, you have to convert into the whole number, because the sample size can never be in the decimal form. So this is the method to find out these all the methods by using Excel, Microsoft Excel. You can download the app add-ins like PHStat. While when you are going to estimate anything, you can do it by using these steps. So these are the complete descriptions are here. So thank you very much for today class. So we have completed the chapter of estimation, and we have completed 4 main methods. The first is confidence interval for population mean when sigma is noun, and the second is confidence interval for population mean when sigma is unknown and sample is large. And when the third method is confidence interval for population mean when sigma is unknown and n is small. And the last one is confidence interval for population proportion, as well as we have seen 2 sample size determination methods. Total are six main the concepts you have learned from this chapter. Thank you very much.